Good evening. Tonight, we're diving into a breakthrough technology that could really change how our cities and maybe eventually our entire world stay connected. It's promising the blazing speed of fiber optics, but with none of the cables.
Just imagine highways for the internet, but instead of being built from concrete and buried wires, they're made of focused, invisible beams of light stretching right across the city skyline. Well, this isn't science fiction. It's the reality a company called Taara is building right now. So let's cut right to the chase. What's the bottom line here? A spin-off from Google's famous Moonshot factory has figured out a way to send internet data using lasers instead of fiber optic cables. This means it's way faster to set up, it's more cost-effective, and it can finally bring real high-speed internet to parts of our cities that have been left behind by old-school infrastructure. Okay, so just how fast are we talking? Well, the system can hit speeds of up to 25 gigabits per second. Now, to put that in perspective for you, that is fast enough to download an entire 4K movie in something like 10 seconds. It's a speed that just leaves most of our home internet connections in the dust, and it can handle the heaviest data needs you can throw at it.
And it's not just about speed, it's about range. It can maintain these incredible speeds over a pretty significant distance. We're talking up to 10 kilometers, or just over 6 miles. That city-scale range is exactly what lets it jump over the tough spots. You know, things like rivers, busy highways, or entire neighborhoods where digging up the streets to lay cable just isn't an option.
Now, this is where it gets really interesting. On one hand, you have traditional fiber, and we all know what that means. Digging trenches, shutting down streets, it's slow, it's disruptive, and it's incredibly expensive. But on the other side, you've got Taara's approach, which completely sidesteps all of that. By just using beams of light, they can get things up and running in a fraction of the time, and for a fraction of the cost. But how is this actually possible? I mean, how do you really send that much data through the open air using just a beam of light? Let's pop the hood and take a look at the core technology that makes these invisible data highways work. It all comes down to something called free space optics, or FSO for short. To put it simply, it uses beams of light. In this case, it's an eye-safe, invisible infrared light to wirelessly shoot data through the atmosphere from one point to another. You can think of it as being just like fiber optic communication, but you get to skip the actual fiber. Now, the idea of FSO has been around for a while, but Taara's big breakthrough, the real game changer, is a brand new chip. This little thing replaces all the big, clunky mechanical parts that you used to need to aim the laser. It creates what's called a solid-state system. That means no moving parts to break or wear out, that can steer the beam automatically with just microscopic precision. And this quote from Devin Brinkley, their SVP of engineering, really shows you what a huge leap this is. He says, "We've compressed most of the functionality of our previous systems into a photonic module the size of a finger." I mean, that's just a stunning achievement in miniaturization. So here's another crucial point. This technology operates in the unlicensed optical spectrum. What that means is, unlike all the radio signals crowded with Wi-Fi and 5G, it doesn't have to fight for space. It's like having your own private, totally uncongested superhighway just for your data, with tons of capacity and way less risk of interference. Okay, so now that we get the technology, let's take a closer look at the actual product that puts it all to work. This device is called the Taara Beam, and we're going to dig into its performance by the numbers. All right, looking at the hard data, you can see that Taara Beam is built for serious performance and flexibility. It has 2 optical ports that you can configure all the way up to that 25 gigabit max speed. But, and this is really important, it also includes standard Ethernet ports. That's the key, right? It means this device can plug right into existing networks without forcing a huge, costly overhaul. And thanks to that incredible new chip we were talking about, this new Taara Beam is a whole lot smaller and lighter than the old model. It's down to just 8 kilograms. That's about 17.5 pounds. This makes it so much easier to install on a pole or a rooftop, which of course is absolutely central to that rapid deployment we mentioned earlier. So we've seen all the numbers, we've looked at the specs, but what does 25 gigabits per second actually mean in the real world? What does this kind of speed really feel like for a business, or maybe even in your own home? Well, for a business, it means running the most complicated cloud software with absolutely zero lag. If you're a creative pro, it's transferring massive 8K video files or huge architectural models almost instantly. And for a family, it could mean backing up a whole lifetime of photos and videos in seconds, not hours. But maybe most importantly, it's a real, practical way to bring true high-speed internet to communities that were just too expensive to connect with fiber before.
But the potential of this technology isn't just about connecting buildings across town. The future for free space optics is looking much, much bigger than that.
To really understand where this is all going, it helps to see where it came from. Taara's tech was actually born from Google's really ambitious Project Loon, which tried to use high-altitude balloons to beam internet down. After Taara became its own company, it perfected the technology for the ground. And now, the future of FSO is pointing right back up, to space. Our modern satellites are gathering just unimaginable amounts of data, way more than our current radio frequency, or RF, systems can handle. Free space optics is really seen as the key to unlocking that massive bottleneck, creating super high-speed communication links between satellites and then back down to us here on Earth.
And all of this leaves us with one last, really interesting thought. For over 100 years, our world has been connected by physical things we can actually see and touch. Copper wires, coaxial cables, and those fiber optic lines buried under our feet. Taara's work is pointing to a totally different future, one that's built on an infrastructure we can't even see. So the question to leave you with is this: is the future of the internet invisible?